Hello friends, welcome to Shiksharthi. In this video, we shall be talking about heights and distances as an application of trigonometry. So let's start. Now in this video, we'll be discussing a few concepts on heights and distances, as we had already informed you that this is an application of trigonometry. So we'll be discussing few concepts, and based on these concepts, thereafter we'll be practicing questions and then solving exercises. Okay, so the very first concept that we need to understand here is, in heights and distances, when I talk about a triangle, let's say if I'm talking about this triangle, a triangle will always have a height, and the height is dependent on the orientation of the triangle. For example, as of now here the height is AB, right? And that now this can be treated as another height, which as of now is the base, which is BC, and the third distance, because all of these are distances only. I mean, for example, AB is a line segment, right? BC is again a line segment, and AC is again a line segment. So in heights and distances, if they simply take a triangle of this sort, you will have three different distances. Among them, two would be considered as heights. And if we take this type of a triangle, in that case, we will be having five different distances. Let's see whether we have five or more than five. So let's say 1, 2, 3, 4 and 5. And how many heights here? So if I talk about that triangle, two heights in any case. So in heights and distances, more or less you will get questions which will be of the same sort. So they can talk about any one of the three, or at least one of the three in this case. And in this case, they can talk about any one out of the five, or at least one out of the five. I hope this has been understood by you. Next point is, we talk about elevation. Now elevation is when you look up to something. And the next thing that we talk about is depression. Please don't get depressed. So this is how it is called. So angle of elevation is now. So when I'm looking up to something, I will have a line of sight. And when I'm looking down towards something, again it will have a line of sight. In either of the cases, whether it is I'm looking up or I'm looking down. For example, let us see, this is the height of a room. The room in which I am recording this session. So let us talk about this side, or let us talk about this board, this whiteboard. So it comes with a height. So let us say the height of this board is what I am talking about. So let us say that this is a board which has been placed on the wall, and I am having a cross-sectional view wherein I am saying this is the top end of the board and this is the bottom end of the board. So now if there are two things as I talked about. So there will be an angle of elevation. So if I say that these are 2 points of observation. Now, where am I observing? So this is the point of observation. I am taking A as a point of observation which is on the ground. Let's say this is the ground. And then there is a point of observation above the ground which is D. So what I'm saying here is, let us say AD is equal to TB. If I take this as TB. So I'm assuming here as AD is equal to TB. Right? So now from ground, if I am looking at the top of this board, the top end of the board, the angle, now this will be known as my line of sight. So my line of sight, when I am looking up to something, will make an angle with the horizontal, the so-called horizontal, or the horizontal. In that case, this is known as the angle of elevation. And if I draw a line parallel to the line AB, which is just like saying AB is parallel to DT. D, this point is D and this point is T. Okay. So in that case, can I say if this is the angle of elevation using the alternate angle theorem? This angle will also be E. Now when I'm looking up to something, I can look at any point which lies from T to B. When I say from T to B, that means I can look up to any point which lies in the line of sight from T to B. That means if I wished, I could have seen up till here only or any other point. In any case, it will be known as the angle of elevation only. Next, when I am looking down from a point, let us say this point is D, and I am looking down towards the bottom of this whiteboard. Let's say towards the bottom of this whiteboard. If I am looking down, so in that case, this will be known as, now this is the angle in any case which it is making with the so-called horizontal. Why do I call it as so-called horizontal? Because I have taken a line which is parallel to AB. Now this line DT is parallel to the line AB, which is why I call it as a so-called horizontal. So this angle will be known as the angle of depression. In any case, this in that case becomes my line of sight. So in either of the case, as we discussed, when I am looking down, I can look, my line of sight may fall anywhere in between top to bottom or at the bottom. When I am talking about angle of depression, the case which I am taking here is, I am taking the angle of depression which this point of observation, from this point of observation to the bottom of this whiteboard. I hope you have understood this, right? Taking this now to the next level. So now when I take this to a next level, what are the kind of questions that they can give to you? So if I am taking a triangle like, so I am going to discuss another 4 concepts, 1, 2, 3, 4. Right? I've discussed already, 2 concepts have been discussed. I'm going to discuss another 4 concepts, and if you go through these concepts, then the questions on heights and distances, they become easier to comprehend and do completely. Okay, so now when I'm talking about this, I can just use a trigonometric ratio. For example, I know that sine 30 degrees is equal to perpendicular upon a hypotenuse. So I can use sine 30 is 1 by 2, right? So I can use it as a perpendicular upon hypotenuse. So sine 30 perpendicular, I can take it as 1x. In that case, my hypotenuse becomes how much? 2x. And using Pythagoras theorem, I can say the base square will be what? The hypotenuse square minus the perpendicular square. Which can be written as h minus b into h plus b, which is nothing but b becomes what? X root 3. So whenever I come across a 30, 60, 90 orientation of a right angled triangle, I can just use these values. And when I say use these values, I am basically talking about PBH, perpendicular, base and height. I'm sorry, perpendicular, base and hypotenuse is what I'm talking about. So in this case, in 30, 60, 90, when I talk about this orientation, 30, 60, 90, then P is, let's say x is to base, which is x root 3, is to 2x. Or I can simply take their values as x, x root 3 and 2x. This is one concept. Now when I take another triangle which is of 45, 45, 90 orientation, in that case I can say that since this angle and this angle are equal, so these two sides would be equal. Okay, and we know that sine 45 or tan 45, you can use any. So can I say if this is my P, let's say this is x, in that case this will also be x, right? Can we find out the hypotenuse? Yes, hypotenuse is x square plus x square under root. So this becomes x root 2. So for an orientation of 45, 45 and 90, what is the PBH values that we are going to use? So let us say P is x, B becomes how much? X again, and H I can use it as x root 2. So after having talked about these two concepts, now these two concepts can be used inside these two kind of questions. So now let us understand what kind of a question is when I talk about this triangle. So you would see here, if I try and relate it with what I discussed here, if I say this is a triangle, so let us say initially the point, now let's say this is the height of a board, the whiteboard that we were talking about, which is AB, and this D is the point of observation, and the point of observation changes from a D to C. Now there are two ways in which the point of observations can change. One is you move towards the object wherein the point of observation changes, and the other is you move away from the object, in which again the point of observation changes. So if I am moving towards the object, let us say from a D to C, naturally the point of observation changes and the angle of elevation also changes. To be more precise, the angle of elevation increases. But if I just take the reverse direction now, and if I say that initial point of observation was C, and now the point of observation changes from a C to a D, naturally the point of elevation changes and the angle of elevation also changes. Thereafter the angle of elevation, you can say, decreases from a 60 degrees to a 30 degrees. Now here I can again use the PBH concept. So let us say if I want to calculate the values of PBH, and if I talk about two triangles, one triangle is triangle ACB and the other triangle that I am talking about here is ADB, and just putting the values in perspective or just taking the ratios, I can do either of the thing here. So in triangle ACB, I know this is 30, 60, 90. So the side opposite to 30 degrees, if it is X, which is the base here. So in that case, the perpendicular becomes X root 3 and the hypotenuse, which is AC, becomes 2X. And this becomes X root 3. Right? Now in the other case, now when I am talking about a 30, 60, 90, when I am talking about this triangle, in this triangle the side opposite to 30 degrees, let's say if it is X, as we had talked about, the side opposite to 30 degrees is X. So in that case, the side opposite to this becomes X root 3 and the next side becomes 2X. Okay, now I know that the perpendicular remains the same for both. You can't change the value of the perpendicular. In that case, what would you do? You would multiply all these values with root 3. Why are you multiplying this? Because the perpendicular value needs to remain the same in both the cases. So in which case, now you will take the final values of PBH for the triangle ADB. So which becomes eventually what? X root 3. This becomes 3X and this becomes 2X root 3. So these are the values that you are going to consider. So now once I know that the length of DB, what is the length of DB now? 3X, and this length BC is X. In that case, this becomes 2X, and the hypotenuse length here becomes how much? 2X root 3. The length of the perpendicular in both the cases remains the same. The base changes and the hypotenuse also changes. Let me do the same thing for the last kind of concept that we are talking about here is, so let us say the angle of elevation changes from a 45 degrees to a 60 degrees when we are moving towards the object that we were observing. So we do the same, PBH. So in one case we are talking about the triangle ACB, and in the other case we are talking about the triangle ADB. We use the same properties as we had used earlier. So now this is 45 degrees. So let's first talk about 30, 60, 90. So if this side is X, this becomes X root 3 and this becomes 2X. So let's say the perpendicular length here is X root 3, base is X and hypotenuse is 2X. Right? So now in this case, when I talk about this triangle, the entire triangle, so this side, which is AB, becomes equal to DB. So if this is X, this is X, this becomes X root 2. But I know that in both the triangle AB, the height is common to both the triangles. So how is the value of the perpendicular different here? So here also in this case, we will multiply these entire values by root 3. So what are the values that we get finally? So these are the final set of values that you are going to consider. So in which case this entire length becomes x root 3, only this length was x, so only length CD becomes how much? X times of root 3 minus 1. This you already knew, and the length of the hypotenuse also changes too. So what have we done? We have understood all the concepts, all the type of questions that can be asked, which we can think from our side, and starting off with minimum 3 different lengths they can talk about in such a case or this case, and in these two cases they can talk about 5 different lengths, all of which we have understood how to do. And are they going to give you any other angle other than 30, 60, 90, 45, 0 degree? No. As of now, no. When it comes to grade 10. Right? So if you understand this thing in detail, it becomes, as discussed earlier, it becomes very easy for you henceforth to attempt any example or a question that comes by your side. If you feel that this video was very informative and knowledgeable, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some specific videos on specific topics, please do not hesitate and put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.